copied and pasted the code that you had. I'm showing a couple of spaces here. So you may have, if you have it here, then it's going to tell you that code inside a function must be indented because everything has to be one indent in because you now have this main function. So you can't have any code in Coral anyway, and some other languages. You can't have any code if you have any single function in your program, then all code has to be inside of a function. And if anything you put back on this, back on this like flush left is going to not be indented underneath the function anymore. So it's gonna, not be inside the function. So it's gonna tell you have to indent it. But it looked like yours was just, for whatever reason, just had two spaces. So putting a space there gets rid of that problem. However, you're still gonna have your output issue because what I mentioned, first of all, I'll just take a second to explain this, and I'm going to cut out a lot of the extra space just so we can see a little bit more of the function. So I'm going to put everything that's indented, I'm going to put it directly under whatever it's indented for, right? So visibly, and then I'm going to put all blocks together, and this, you're actually never anywhere using this value, so this value just needs to not even be there. So this 4 will take the space out, and all I'm doing is taking the spaces, a couple of the spaces out. Alright, so this allows us to see, and then we'll take a couple of these spaces out. So we can almost see the entire program now. And maybe we'll go ahead and chop that up there. And I guess I'll chop this. Alright, that should be, we should be able to see that. Normally I would put a space between here, but I just wanted to have everything visible in one, aside from the fact that we can't see that, but everything else is visible. So oops, I put that there. Okay, so when you run this, it's jumping straight past this function here because the function is not called main. So it knows, hey, there's something here we might come back to later, but we also may not, and so it's just going to skip that. It doesn't, that's important to understand the way that a program actually gets parsed. It doesn't start, it doesn't do anything that's in here. It doesn't run this part of the program. It skips straight ahead to the main function because that's where the actual program is going to go. And there's nothing for it to do on these 3 lines except for reserve these spots in memory. So it's reserving a spot for something called user vals, something called min value, and something called x. And what type of spot it should reserve, it's being told right here, integer array with 5 slots, an integer and an integer. So when we look over here, before we click enter execution, there's nothing there. So the first thing it does is it initializes the variables. Boom, bam, before it runs any line of code. Then it jumps to the next line of code to run. And over here, if you look, user vals is everything inside of here. And the type is integer array. Min value type is integer, x type is integer. Now, user values has 5 slots, counting from 0 to 4, and it has a size attribute, which lets you know how many slots it has, which is why we can use the user vals dot size. All right, so in our input box, we want to just type in 30, 50, 10, 70, 65, which was the values from here. 30, 50, 10, 70, 65. So it's skipping right down here, and here's the problem. Your input is not actually getting run. If we watch what happens, and I'm just going to do instant, click step, first thing it does, when you declare a variable, it initializes as 0, but we're expressly saying start at 0, and then count by 1, but this actually happens after everything that's underneath the for loop. So the first thing it does is it start at 0. Now check if 0 is less than this value here. But this value here is min value, and min value we don't set min value till later. And min value is going to be the smallest value in here, so we don't really, even if for somehow, it's impossible, but even if somehow we manage to get this array and pass it to our function and have our function find the smallest integer for us and give it back, we would still get some funky value for this, because this is going to, like in this case, it'll be 10, but in another test case, it might be 30 or it might be 100. And you certainly don't want to run through and try to get 100 inputs. So we need the number of inputs that we get to be the same as the number of slots in our integer array called user vals. So there's no reason for this to be any different than any of these other ones. So this is the problem right here. You fixed this by pulling it out of the loop. So we're not going to waste time running that code every time after we put another input in. However, we're never even going to enter this code. We're just going to skip right over it, because min value is equal, it starts out at 0. And x is 0, and 0 is not smaller than 0, so this get next input never even gets processed. Then the reason why you're getting output of all zeros is because there are already zeros in the array. We were going to refill it with the user's values, but they start as zeros. And the min value is so this is going to check, and that's where it actually steps into the program, into the function, and now it's going to go through and check. It's going to first assign minint to slot 0, which is equal to 0, and then it's going to check, is 0 smaller than 0? No. No, no, no. So it's never going to reset minint, because minint is 0, and user vals, none of the other slots are lower than 0. So it just keeps it at 0. And then it comes back, it replaces all this line right here with a 0, and stores that 0 in min value. And then we enter into our next loop, and it resets x to 0. And then it says, check to see if the value of x, which is currently 0, is less than the size of user values, which is 5. Yes, it is, so it's going to run the code, which is put user value slot 0 to output. So put 1, 0. Then it's going to go add 1 to x, so x will equal 1. It's going to say, is 1 less than 5? Then it's going to say put user values 1, so slot 1 to output. And then it's going to add 1 to x, so x is 2. Is 2 smaller than 5? Yes, so we run the code, and the code says put whatever's in user value slot 2, which is another 0, and so on and so forth. And it's not a forever loop, because x is going to end up right there equaling 5, and 5 is not less than 5, so then it stops running this code and the program is done. So you may have noticed your zeros are all next to each other. You're not putting any spaces in, so we might as well just go ahead and throw the spaces there now while we're at it. So now if we were to run the whole program, it would get 0 with spaces. And this is an infinitely never going to happen loop, because 0 is 0, not less than 0. So we need to change this to, you could hard code it with a 5, and just like you could hard code this with a 5, because we know that in this case we want it to happen 5 times, because our integer has 5 slots, and we need to get 1 input per slot. However, doing that means that if in the future the client came back and said, you know what, we are actually going to have 10 numbers, or for example, our RGB values code from back in chapter 3, we could have written all of this, but instead of calling it user vals, we call it, like, for example, RGB values. and then put those to output, and we still could have called this exact same function and passed it our RGB values array that only needed 3 in there because we have red value, blue value, green value, right? Red value, green value, blue value, RGB. And we would, if we were going to do that, we would change this to a 3, and then we would have to change this to a 3, and then we would have to, if we hard coded this to a 5, we would have to change this to a 3, do all that, right? Or if the client said, we want 10, then we have to change all of these to 10s, find everywhere in the program and maybe in every other program. For example, had we done that here, had we just done 5 here, let's say we used this function in 10 different programs that were all getting different types of numbers, but for some reason we always wanted them to subtract the smallest one from the list, whether it was RGB values or whether it was here in this program, and we had 8 other programs. We'd have to go into each one of those other programs and change all these hard-coded places, and then we couldn't, if we change this to a 3, for the case of, for the case of the RGB values, it would no longer find the lowest value if we had 5, because it would go 1, 2, 3, and then 3 would stop being less than 3, it would stop running this code. So if we had smaller values here or here in the other slots, we would never even know. It wouldn't, minint would not actually work, right? So we would want this to be uservals.size. That way, whatever size array we get, whether it's 3, whether it's 10, whether it's 50, whether it's 5, we'll actually find the smallest integer there. And then we want to go ahead and make all of these the same, so that if in the future this ever needed to be changed, all we would have to do is change this right here. We change this to a 10, and you notice now there are 10 slots, and the size says 10. We could change this to 99, and we get this nice, huge, long list of 99, and the size becomes 99, right? So, where'd my thingy go? There it is. Let's get that 99 out of there. Run like the wind. All right. Now we're back to 5. So that's why we use uservals.size. And using min value here doesn't make sense because we don't have min value set as anything yet, and we specifically want to get one input for every slot that we have. So if we do this, now we can step through and we can see it's going to check, is 0 less than 5? Yes, it is. So we run the code, which is to grab the first input and slam it into slot 0, which we do. Then it's going to do it again. It's going to grab the second input, slam it into slot 1, and it does, and so on and so forth. Then once we have all of those, and x, it adds 1 to x is going to then equal 5, and 5 is not less than 5, so we're now done with this. We move on, and we bust out of the for loop, and the next line of code is running this function, passing it these numbers that are stored in memory. It doesn't get the variable name, it doesn't get anything else, it just gets these numbers, and of course the attribute size comes with it because that's an attribute of the array. That has nothing to do with the array name. You can put dot size after whatever the array name was. But in our function we do call it the same thing that it was, but anyway, that's just important to realize that this array is a different array with the same numbers than this one. They're different variables. In any case, then it's going to go through that and it's going to find the lowest value, which in this case we can look at and easily know is going to be 10. And it goes down and it finds that it's 10, and it brings the 10 back, puts it here, slams it into min value, so we're going to see min value right here. Go to 10, there it goes, and now we can do our output, which is to take slot 0, subtract 10 from it, and then to move on to slot 1, subtract 10 from that one, 10 from that one, 10 from that one, 10 from that one, and output them all with nice little spaces in between because we added that line. 20, 40, 0, 60, 55, and the last little space, which it told us to go ahead and add for coding simplicity. Follow every output by a space, even the last one. If we didn't want a space on the last one, of course we could always do an if x is not equal to, and then do user vals dot size minus 1, because the last slot is always going to be the overall size minus 1. And of course that needs to be there. If you have 5 slots, it means starting from, because the count starts at 0, 0, 1, 2, 3, 4. If we had 10 slots, the last slot would be 9. Size would be 5. Size would be 10. Slot would be 9. In the case of 5, the size is 5. The last slot is slot 4, position 4. So we can do user vals dot size minus 1, and that would output everything but no space on the end. Of course, that would fail this check because this check specifically said go ahead and put the space on the end. Notice their white space right there. So yeah, we just leave it like that, and that is that. Hope that helps.